We're going to go ahead and take a look at number 17 from section 7.3, which deals with systems of linear equations in two variables. Number 17, we are provided the following system. We have an x plus 3y, which equals 5, and we also have a 4x plus 5y is equal to 13. And we are told in the directions that we need to use the substitution method. So one of the first things that I would suggest doing is I would maybe focus on working with the first equation in the system. Basically because it's going to be really easy to isolate or get x on its own. Notice that I'm going to have to do a simple subtraction and then I'm all set. So just to be a little bit clearer, I'm going to go ahead and rewrite that first equation so I have some room to work with it. Subtract 3y from both sides. And in a roundabout way, I now know what x equals. I know that x is equal to negative 3y plus 5. This is described as defining x in terms of y. So for example, if any of you have any sort of siblings or maybe close cousins or something along those lines, and if you've ever had people describe you in reference to your sibling, so maybe, oh, they're not as athletic as their older brother, or they get better grades than their younger sister, or something along those lines, then you have a comparison where someone is describing you in terms of someone else. So that's what we're doing here. We're describing x in terms of y. So what we can go ahead and do then is, if I know that x equals this, I can go ahead and plug it into the other equation. I do want to stress to you that you do not want to plug this x value back into the first equation. Essentially what will happen is that all of your variables will cancel out, and that will mislead you to conclude that the answer is infinitely many solutions. So make sure that depending on whatever equation you use and isolate, you plug it into the other equation. So what we have here is I will do 4 times, and I'm going to plug in that negative 3y plus 5, or substitute it in 4x. And I have plus 5y is equal to 13. And the whole reason why I want to do this is note that now all of my attention can focus on y and y alone. I don't have to worry about what x is doing in this case. So I'm going to distribute and get negative 12y plus 20 plus 5y is equal to 13. Then I'm going to combine like terms. So this is going to be negative 7y, so negative 12y plus 5y will give us negative 7y, plus 20 is equal to 13. Subtract 20 from both sides. You get negative 7. And now in order to undo that multiplication, I'm going to use division. So now I have y is equal to positive 1. So the good news is that I'm halfway done. So now I can go back to my first equation, and I know what y is. So I can do 3, instead of times y, I can do times 1 is equal to 5, and then continue to evaluate from there. So I have x plus 3 is equal to 5, subtract 3 from both sides, and I get x is equal to 2. So our final solution we want to write as an ordered pair. And note that we want to write this in a specific order. The first position holds our x value, and the second position holds our y value. This is our final solution. Please bear in mind that when you are checking to find out what the second variable is going to be, you can plug it into either one of the equations. So let me demonstrate that. So say I take this y equals 1 and I put it back into the second equation. Five times 1 is 5. Can subtract 5 from both sides. This gives me 8. I will divide both sides by 4. X will still equal 2. So bear in mind that when you are working with in determining the second value, it does not matter which equation you plug into. I hope this helps. If you have any additional questions, please let me know.